we are live. This is Math 60 Intermediate Algebra. This is section 1.4. It's a bunch of simplifying. It's a bunch of evaluating. It's so much fun. We're having a great time. This is part 2 because there was so much amazing math that we couldn't fit it all into one variable. Yes, exactly. One variable or one video. There are a lot of things we can't fit all the math into. Breadbox would be too small too. Okay, so where were we? Well, we had just learned a bunch of properties, which you're going to start using without naming. And many of you already know them: the commutative property, the associative property, and the distributive property. We've got 2 other things that I want to introduce. Now, in this chapter 1, we're talking a lot about vocabulary, a lot about review, and some of the things I'm going to say, we're not going to say to you again for possibly years of math, but I'm trying to plant little seeds that will grow into beautiful gardens in your brain. And no, not a parasitic weed. Hopefully it's a beautiful garden. So we've got a really weird word, and I have never wrapped my head around this choice of words. Somebody else got to name all these things, and the word is identity. Identities are special numbers that don't change the value of other numbers with certain operations. So, what is the additive identity? So, in other words, I'm asking 3 plus some magical number equals 3. What do I add to 3 that it will not change the number? You're right. The question mark must be 0. 0 is the additive identity. Now, I think the concept is really cool. I just think the word, I have trouble with the word because the word has other meanings in English. So they kind of bump together. But of course, you know what's most important. Math is always most important. So if I add 0 to any other number, 1,000,000 plus 0 will be 1,000,000. Yay. Okay. So is there, and this is one of the funnest phrases to say, even if I'm not fond of the word itself, multiplicative identity. Wow, that makes you sound, I feel like I'm wearing a turtleneck collar and tweed jacket just saying that. Multiplicative identity. Oh, but you're not considering the multiplicative identity. Why, yes, I guess that changes the whole argument. See, you could have lots of wonderful imaginary conversations with all of these terms in math I'm teaching you. So the multiplicative identity, there we go. 3 times a mystery number gives me 3. So is it 0? And the answer is no, because 3 times 0 would be 0. That's not going to work. I want a number that leaves 3 unchanged. You're right. 3 times 1 is 3. So 1 is the multiplicative, there we go, identity. Ugh, spelling. Oh, man. There are those who suggested I went into math because there's a lot less spelling. And they aren't necessary. They aren't not wrong. Oh, now I've got multiple negatives. Never mind. So basically, we've got 0 is a very special number and 1 is a very special number. 0 is special. Well, 0 is a superhero because if you multiply anything times 0, you got 0 and that's done. But when you add it, it doesn't change the original number. So this is like if you're going to be in an additive relationship with someone, get into an additive relationship with 0 because 0 won't make you change for the relationship. Isn't that lovely? And if you're in a multiplicative relationship with someone, get into a multiplicative relationship with 1. 1 won't try to change you. 1 will leave you and let you flourish as the beautiful person you already are. There we go. Okay, so we got 2 identities here. And then we're going to move on to one more concept before we get to the show. This is very exciting. Like terms. Again, Somebody else named all these things. And when I am king of the universe, maybe we'll come up with some different names. But like terms means they match. It means exactly matching variables. Okay, so let's look at, I'm going to pull out the yellow and the blue, my two favorites, as is probably obvious at this point. And I am going to look and I'm going to see, okay, 3x. There we go. I got a 3x. Are there any other terms? You know what? I'm realizing that's very small, so I'm going to write it big as well. 3x plus y minus 2x plus 2y. Okay, so 3x. I'm going to box it because if I try to, color it over, it'll be Smear City. It might actually be Smear County. It's so big, or possibly even Smear Township. So, it's intense. I got 3x. Do I have any other x's? Yes. I have this 2x. Now, I'm just going to yellow out the x part, but that minus sign can be considered part of this term. So it could be negative 2x or it could be minus 2x. It's a subtle distinction. I'm just going to look at the terms without signs. Okay, you could look at it a different way. So those are my here, I'm going to give this a little bit. There we go. I'm going to attach it. I lied. I'm going to go ahead and risk smearing. There we go. Okay. And then do I have any other terms? Yes, I have a y. Now y is getting blue. And you might ask, why is y getting blue? And I will say, well, these don't match. That's an x, that's a y, different variables. This is an x, that's an x. And you might say, well, the numbers are different. And I say, you know what? Numbers are really easygoing. The numbers don't have to match. It's the variables that have to match. Exactly matching variables. Okay, any other y's? Yes. Look, there's one right here. The 2y. Okay. So what am I going to do? Well, some of you can do this in your head. I can't. I don't trust my head so much. Sometimes the stuff that goes into my head comes out in a different order, and it's really annoying. But it hasn't stopped me from being a math professor, which is pretty cool. So I'm going to take the 3x and the 2x, but the 2x is going to drag that minus sign. 3x minus 2x, so that they are, living, you want to bring the family together. It's nice to get the family together. This family is getting along just fine. There's a little bit of contention, but they'll work through it. I trust. And then I'm going to bring the y's together. There's the y and the 2y. Now, here's the thing. When you get long lines of numbers, these aren't that bad. These aren't that terrible. But when I was in school, I learned a trick. When I take something from a previous line and I write it in the new line, I put a little dot underneath it to tell myself I've already used that one. The y is here, so I use that one. The 2x is here, so I use that one, and the 2y is there. And that way I can look back up there and say, okay, I got them all transferred to the next line. This is one of those helpful hints because I have to double check everything. Now I'm going to combine the x's, 3x minus 2x, 3 of something minus 3 apples, 3 pens, take away 2 pens is 1 pen. 3 x's minus 2 x's is 1x. And then y plus 2y, 1y plus 2 y's is 3 y's. And then now I'm going to make it fancy. Generally speaking, we don't put the 1 in front of the x. It's like when you don't have to say 1 apple, you say an apple. Ta-da! Couple answers, because I know you're wondering, do you have to take 143 steps to get here like I did? No, absolutely not. Again, I'm trying to make sure, because you cannot ask me questions right now while I'm making this video. Again, unless you can send them to me psychically. So I'm listening, just in case anyone is sending me psychic messages. And the answer is yes. the last episode of What We Do in the Shadows was really awesome. Thank you, random person who sent me that psychic message. I loved it too. But I don't hear anything about the math. So the problem is that I'm writing out as many steps as I think hopefully will make it clear. So you can skip as many steps. Some people can go directly from the problem to the answer in their head. That's awesome. You guys are superheroes. Everyone else, also superheroes. Again, math doesn't change whether you're awesome or not. It just makes you able to do more things. You can be awesome plus math. And then the other question is it okay to write this one in a different order? Yes, but there's a caveat. You guys are in Algebra 2 now. In Algebra 1, which was Math 40 at City College, we just say, look, if you get to the end of the problem, it does not matter how things look. Just get there and we're really happy. Algebra 2, you've had some practice under your belt. You've done a whole semester of algebra. You're starting to feel more confident. Now we're going to start to make things look fancier. And one of the rules is, generally speaking, don't let the rabbit on the table because, you get rabbit for everywhere. But also, X's come before Y's because of the alphabet. So generally, we put things either in alphabetical order or in something called descending order, which we'll talk about later. Okay, woohoo. We did that. Are you guys ready? I'm so excited. I can tell you're so excited. I can hear you being really so excited. Okay, so after all of that, then I spring on you horrible looking problems, which is, it's pretty much the way I work. This is on brand for me. So using all of the things we just talked about, let's play with these. Oh, there was one thing I wanted to say before we do the horrible fraction problem. And that is, what was it? I totally forgot to say this. So let's go back and do it. What was it that allowed me to bring the X's together and the Y's together? It's the commutative property. Now you would say, wait a minute, there's a minus there. You can't have the commutative property with the minus. And my answer was, remember how I tucked that minus into a little ball so it didn't hurt anyone? As long as you take the minus with you wherever you're going, you're allowed to commute with the minus. You just tuck it in your car and then go beep, beep. Or on your bicycle. I know some of you are on bicycles or skateboards, or scooters or wherever you're using. Tuck that minus in so it doesn't hurt anyone, and you're allowed to go anywhere you want, except not on campus currently because they were quarantined, but Okay, so commutative property, yay! I'm just going to show you all the problems. I know, I know, don't worry about the next one. Let's do the one we're on. Don't worry about the next problem. Worry about the one we're doing. Okay, first thing. You've got a couple options. One of the options is to simplify inside. Can I just suggest for this problem, you don't want to do that? You could, but it's not going to be fun and it will not help. And I'm just saying that because, trust me, I wrote it. So what I'm going to recommend is that we actually use the distributive property first, because multiplying by 6 is going to cancel these denominators, going to make everything a little bit easier. So I've got 6 times x over 3 minus 6 over y over 2 plus 6 over x. Now this is something peculiar that I like to do. Everybody's got their own style. There are styles. Just like you would have a style with writing an essay, there are styles when you're writing math. My style is that I see positive times a positive gives me positive. Positive times a negative gives me negative. Positive times positive gives me a positive. And I push the 6 all the way past the sign. So I just have the sign there and I don't worry about it. You can do this differently. Your work can look different. The goal would be that our answers are the same. But our work, we may take different amounts of work and different steps to get there. Because there are a lot of in math, you've got a lot of choices you can make. I'm going to go ahead and rewrite 6 in 2 of these terms. Each piece between the pluses and minuses are called a term. So for this term, I'm writing my 6 as 6 over 1. I'm allowed to do this, and it's going to help me cancel. The 3 and the 6 cancel because I can see that the 6 is on top over 1. So I cancel 1 over here. 3 canceled leaves 1. 3 canceled leaves 2. 2 canceled with 2 gives 1. 2 canceled with 6 leaves 3. And then I've got 2 times x over 1 minus 3. Oh, it's really 2 over 1. 3 over 1 times y over 1 plus, and I can just go ahead and multiply this. This is 6x. This is really 2x minus 3y plus 6x. And then I say, oh, wait. Look at this. There's a 2x here. There's a 6x here. So altogether, I don't have 2x and 6x. I actually have 8x minus 3y. I mean, it got complicated enough. I'm going to box it because it's a little hard to follow. What do you guys think? Kind of woohoo? Again, same caveat. You may use different steps. You might not show as much as I do. You may show more than I do. So it's all good. It's all good. If you ever are curious, you're always allowed to show your work to someone. I mean, if you're on Muni and you just start showing your math to people, they might ask you to leave because that can be a little bit stressful for some people. They're not ready for math first thing in the morning. So I would recommend showing your steps to me or a tutor if you ever want to say, hey, how does this work look? Am I doing the work the way that you'd like to see? Is it making sense? And we will absolutely help you with that. So our assistance does not end at the correct answer. If you want to know stylistically how you're doing, let us know. Okay, I'm just stalling, and it's time to stop stalling because what in the world is here? What is even going on here? There's nested grouping symbols, there's decimals, it's decimal-rama, it is all the things, and yet we're going to survive it, okay? Woohoo. Shall we bring in Godzilla? Godzilla, give me strength. Again, Godzilla knows all about how hard it is to face impossible odds and still try to save your children. Okay. This is a hard problem. I'm taking off the glasses. I know, so I can really see. I've got negative 0.5 times the quantity 3 times the quantity x minus 4 minus 2 times the quantity x plus 2 minus, and Godzilla's going to sit over here, minus 0.7 x minus 3 times the quantity x minus 3. So some things that I want to point out. The brackets here only extend this far. The 0.7 times the quantity x minus 3 is its own thing. So this is its own piece. There are actually 2 different pieces. And so it's easy when you're looking at a problem to try to smash it all together. It isn't always smashed. Math is frequently awkward with weird things sticking out. So let's take a look. I'm going to start with this chunk because generally speaking, you're going to go left to right. If you've got 2 pieces to work with, we're going to work left to right. The other way to look at it is I've got these grouping symbols, but then I've got these smaller grouping symbols, so I should work there. So I'm actually going to start right here inside there. Let's see if I have enough room. 0.5 times all of that. Okay, so that's all the outside pieces. I'm going to start with this, and I'm going to use the distributive property. 3x minus 12, and then I've got minus 2 times the quantity x plus 2. Okay, so that's what I got right there. So I did this part, and that's right here. Okay, next up, I'm going to do this. Now notice how this minus 12 and minus 2, see how they're winking at you? They are totally winking. Don't fall for it. This 2 is already involved in a multiplication. It's way too busy to subtract. It's got to do the multiplication next. So I'm going to do this part right here. Negative 0.5 times the quantity 3x minus 12. And then I'm going to take the negative 2 and I'm going to let it go multiplying through. Minus 2x minus 4. 0.7 times minus 0.7 times the quantity x. Oh my goodness. Oh, and I don't have my magical eraser, so we're just going to have to look over there. It's a pterodactyl. I don't know what happened. That's a 3. I don't make mistakes like that. Oh my gosh, I constantly make mistakes like that. Okay, so we'll take a look at it. I believe our next step is to, inside of here, combine like terms. So let's smash all the x's together, smash all the numbers together. I've got a 3x here and a minus 2x there. Oh, that's kind of dark. Sorry about that. And I've got a minus 12 and a minus 4. So I've got 3x minus 2x. That gives me 1x. Minus 12 minus 4. I spent $12. I spent $4. Altogether, I spent $16. What do you think? Each step, I'm putting in an equals on the left. Some people do the equals on the right. I never got into that, but if that's your thing, go for it. You rock that. And now I'm still having to decide between which one we're going to do. And the official rules say whenever you have to decide, you have 2 things that are the same level. I've got a distributive property here and a distributive property there. Move left to right. Now, in reality, you may have enough experience to know that you can actually do this and this at the same time on the same step. But if you don't already know that, don't do it yet. Okay, I'm going to do this guy right here. Negative 0.5 times x minus 0.5 times negative 16. Now, here, when I did the multiplication, negative 2 times 2 was negative 4. That was easy to do in my head. Negative 0.5 times negative 16, I'm writing down so that I'm not trying to do too much in my head. I know I have a certain amount of dyslexia. It's going to make some of the stuff I do in my head kind of get a little wonky. Sometimes when it goes in, sometimes when it comes out. I never know. So if I think things are going to be complicated, I write it down so that I can retrace my steps if I have a problem. Okay. Let's see if we can get through this. I don't know. I may need to use another sheet of paper. Now that I can look at this, I see negative times a negative. So I know this is going to be a plus. This is basically half of 16. I could use my calculator, or I could just say, oh, half of 16 is 8. I happen to know that this third problem, this last problem, I'm just pointing out one small detail, and so it's very short. So I'm going to take that space, and I'll use the rest of this space. Okay, next up, I simplified this part right there, and now I'm going to go ahead and do the second set of distributive properties. So I get negative 0.5x plus 8 minus 0.7 times x minus 0.7 times negative 3. That's the second part. That's this part right here. Let's see. This was blue before, so I can do the blue right there. Okay. Negative 0.5x plus 8 minus 0.7x. And then I can go ahead and multiply. Now, in my head, I happen to know negative times a negative is going to be a positive, but you could also do it on the calculator. So on a calculator, a negative sign is different than a minus sign. The minus sign is usually big. It's usually right next to the multiplication and addition. This is a minus sign. A calculator sees it just as a minus sign. If you try to use this for a problem like this, your calculator will probably throw up on you. That's not pretty at all. It'll just say syntax error, but it's basically going, bleh, I can't deal with that. It's like it has a lactose sensitivity, but it's a minus sensitivity. So on this calculator, you'll see, I don't know if you can see, it's little tiny, but it's a minus sign inside parentheses. That's your negative sign. Some people have a plus or a minus. So on a calculator, you're looking for a minus in parentheses or sometimes a plus or a minus, and some other calculators have other keys. You want to look for it. And again, if you can't find it on your calculator, send me a picture. Let's Zoom, let's talk. Well, the tutors can help you find it as well. Okay, so I've got the opposite of 0.7 times negative. Oh, I did it. The opposite of 3. There we go. And I get 2.1, and it confirms, in fact, it is positive. Okay, so I've got negative 0.5x minus 0.7x. I'm going to bring the x's together. I have to include this minus in the 0.7. So see how that minus stays there. Then I've got plus 8 plus 2.1 negative 0.5 minus. Now I can choose, because this is between two things, I can use a minus 0.7. This is negative 1.2, which I could have guessed. 5 plus 7 is 12. 8 plus 2.1, 10.1, and we did it. Oh my gosh, you guys, we survived. Look at that. Isn't that a thing of beauty? I don't know. You may think that that's pretty yucky, but I think it's pretty amazing. Each of these steps, you could make a mistake. So if you can get all the way through, I applaud you. If you can't get all the way through, you are still the awesome human being you've always been. You just are an awesome human being who had trouble with this problem. That's the only difference. Okay, one more problem, and then, oh my gosh, this video is almost 30 minutes. That's pretty long. So let's get ready to be done with this. Some people get weirded out when there's just a lone minus out in front. And I wanted to point out that this can be seen as a -1 if you like. You don't have to, but you can think of it as a -1. You can also think of it as just a minus. So if you are an emo person, what we used to call goth, and you're sad, what we used to call baby bats, and you like death and sadness and sad poetry and lots of eyeliner, and man, I miss the 80s. If you're sad and you're around someone who's happy, it's not going to go very well. But if you're sad and you find someone who can be sad with you, -1 times x is the opposite of x. -1 times -6 is +6. The two minuses, two goths together, two emo kids, two baby bats are so happy. Oh, I can't make it work in the... Oh my gosh. Oh yes, I'm a professional YouTuber. Okay, so I just wanted to point that one out. Woohoo! Good luck on the homework. Remember, sometimes it's going to be really hard. Don't spend more than half an hour. If you spend 5 minutes on a problem and you're ready to ask for help, ask for help. You do you. You choose when you need help with something. And good luck. And I will see you guys in 1.5. Woohoo! Math on.